Hey guys, this is just a really short video helping you work on the second page of the topic 22 specific parallelograms worksheet. This is what it looks like on the front. So that's the front of the worksheet. I'm just going to do proof 1 and proof 4 for you guys. The rest I want you to do by yourself. First period, we've already done proof 1 together. It's also on your homework from last time. I'm going to talk through it again, and then I'll talk through all of number 4. So the first thing I want you to remember is when we're using properties of one of our quadrilaterals, and we use a statement. So for instance, because we know this is a parallelogram, we know the opposite sides are congruent. Well, if I want to make a statement about that, I say that my statement would be that the sides are congruent, or like EF is congruent to HG. But my reason, I can't just write properties. So instead what I'm going to write is the blank of a blank are blank. And what we mean by that is what is it that you're comparing? So is it sides, angles, diagonals of what's the shape type, and then what's the rule? So like the sides of a square are congruent, or the opposite angles of a parallelogram are, or something like that, or like the diagonals of a parallelogram bisect each other. So that's what we mean by the blank of a blank or blank. So let's see if we can do number 1. So our first thing is always our given. This little symbol here we use for parallelogram, but we'll try to be really clear for you guys on a quiz or a test, so you know that this is saying that we have a parallelogram called parallelogram EFGH. I'm not worried about this stuff here, because if you name something correctly or label it, so see how we have parallelogram EFGH, we always start with a letter. So E doesn't necessarily really matter where you put it. And as you go around clockwise or counterclockwise, it doesn't matter. You should see E, F should come next, G should come next, H should come next, which means if you label it the correct way, EG has to be the diagonal, FH has to be the diagonal. So I don't feel like you necessarily have to put this, but you do need to have this. So what's my statement? I have a parallelogram, and my parallelogram is called EFGH. And we need to know it's a parallelogram because our properties don't work unless we know what kind of shape it is, right? So the next thing it says is the diagonals of a parallelogram bisect each other. Well, that literally means that this and this are the same, that this and this are the same. So we need to write that as our statement. So our statement would be that segment EK is congruent to segment GK. Now remember, we can't say that their lengths are equal yet. This literally just says that they bisect each other, which means the two parts are congruent, the two halves. And then we're going to have HK is congruent to FK. Okay, here's our picture. Our goal is to prove that EFK, well, here's triangle EFK, is congruent to triangle GHK. We want to show that those are congruent. Well, in order to show that two triangles are congruent, we have 5 ways to do that. And our 5 ways are SSS, SAS, ASA, AAS, and HL. Now, they've already told us what we want ours to be, and if I had it, you could have picked, and in this case, you can actually do a couple different types. For instance, you could do vertical angles to get SAS, but we want to do SSS. It already tells us that. In order to get SSS, I need to find a way to say that that side is congruent to that side. I need to find a way to put segment EF is congruent to segment GH. Well, wait a minute. Opposite sides of a parallelogram are congruent. That fills the blank of a blank are blank. So the opposite sides of a parallelogram are congruent. That's my property. Fantastic. Okay, well now I have all 3 sides for both, and the 3 sets of sides are all congruent. So now I can say that triangle EFK is congruent to triangle GHK. So let me flip over to our next proof. I've already started this with both of your classes, so I'm just going to leave up, I think both of our classes at least got this far. Let's look at it though. It says angle P and angle S are supplementary, angle Q and angle R are supplementary, and angle P is congruent to angle R. So I've already written that in my given. I know it's really, really small, but I'm really just copying this over here. And then I like to draw on here, so ignore the green for now because I was doing that in class. They told us that these 2 angles were supplementary. They told us that these 2 angles were supplementary, and they told us that those 2 angles are congruent. We need to prove that we have a parallelogram. And if you remember from last class, we have 6 ways to prove that a quadrilateral is a parallelogram. Only 2 of them include angles, though. So if we want to prove that we have a parallelogram, So to prove quadrilateral is a parallelogram, we have 6 options, but we only have 2 options that include angles. And our 2 options that include angles are that both pairs of opposite angles are congruent. And our second option is to prove that that 2 consecutive why do I say the 2 consecutive angles to a given angle are supplementary. So we can prove that these 2 are congruent. It's possible to do, and then we can use the first one. But for this proof, it's actually going to be a lot easier to show that P is supplementary to Q and is also supplementary to S, partially because we already know that P is supplementary to S. They've already told us that. So what I've done in the proof so far is I've put in my given. And if I'm going to want to manipulate these, I need to get them into equation form. So the first thing I did is I said that the measure of angle P plus the measure of angle S, and I had messed this up in 5th period. So the measure of angle P plus the S is 180. That's what it means to be supplementary. And same for Q and R. The measures of angle Q and the measure of angle R are also 180. That's definition of supplementary. Okay, I'm also going to turn that the angle P is congruent to angle R into like an equation form. So the measure of angle P equals the measure of angle R. Okay, our goal is to get that P and Q are supplementary. So notice in green here, I'm saying I want to show that this is supplementary to this. Well, that's done. I want to show that this is supplementary to this. That's what I need to do. So I need to find a way to get the measure of angle P plus the measure of angle Q equals 180. That's what I need to do. So the measure of angle P plus the measure of angle Q equals 180. Well, fortunately, I'm in luck, because if you look at this one right here, okay, we have the measure of angle P, and because of this statement, we know that the measure of angle P and the measure of angle R are the same. So I can take this and substitute it in there. That's how I get from this stuff here to this. I'm substituting this in for this. Okay, well, in order to say that this is a parallelogram, I need that P is supplementary to S and Q. So I need to turn this into angle P and angle Q are supplementary. I'm just putting it back. That's going to be definition of supplementary. And then 6, my last thing, now that I have both of them, I can now say that quadrilateral P, Q, R, S. Now, let's go back to this again really fast. Sometimes we use this as a parallelogram, sometimes we use it as a quadrilateral. That's why I would always put, I would just always assume it means only quadrilateral, and in the future we'll make sure to give you good verbiage like we did we didn't do a good job on number 1 earlier, but we can work about that in class. So quadrilateral P, Q, R, S is a parallelogram, because really all this picture shows us for sure is it's a shape with 4 sides. And now we have to give a reason. I'm not going to be super picky about how you do this, but I want to find a way to recap this really fast. So I'm going to say one angle was, or is, I guess I should say, is supplementary to its 2 consecutive angles. Okay, so there's proof number 4, and I'll give you guys to take some time and look over that. Let me explain what we want for 5 and 6 really fast. It says for proofs 5 and 6, you must prove that this shape is a parallelogram using a different method. So in both cases, we're telling you that this is congruent to this. And we want you to use 2 different methods to prove that this is a parallelogram. So in other ways, remember, we have 6 ways to prove something is a parallelogram. You need to use 2 different ways, one for here and one for here. So that's your homework. Remember, your homework is to finish this whole packet. This front piece of paper should be pretty quick, and now I've done 2 proofs for you on this back paper.